All right, guys, welcome back to the Viking Initiative for Building Excellence. Today, we'll be covering math, and it's lesson three of the ACT course from Vibe. All right, so as usual, we'll start off with the structure and timing of the section. So for math, for the paper ACT, it's 60 questions in 60 minutes. So yeah, the old ACT had 5 answers per question. Multiple choice, you're allowed to use your TI-84 or graphing calculator, anything, but no Desmos. So yeah, 60 questions, 60 minutes. My recommendation is to try and finish it in 57 minutes, giving yourself 3 minutes for review over the questions you didn't remember how to do. And then for the digital ACT, it's a little bit different. It's 45 questions in 50 minutes, and it's limited to 4 answers per question rather than the original 5. So with this, I recommend for you to try and finish it in 48 minutes, giving yourself 2 minutes for review. Sorry, that's a typo there. But yeah. So some of the question types in math. So firstly, it's preparing for higher math. This is basically like the largest part of the ACT math exam. So it's 57 to 60%. It includes number and quantity, which means real and complex numbers, ratios, units, all of that good stuff. Algebra. In this, you have expressions, equations, inequality systems, and functions. And then, yeah, functions is a separate one too, where you have interpretations, graphing, modeling, and transformations. And then, yeah, it's sort of split weirdly. Integrating essential skills basically just means like putting all of like the skills together. So they'll ask like more difficult questions in things like geometry, where you have shapes, angles, circles, volume, and trigonometry, statistics and probability with data interpretations, distributions, and probabilities. And lastly, proportional relationships like percentages, rates, and proportional reasoning. Then lastly, you also have like modeling throughout the entire thing. So like understanding like real life models. They'll give it to you. Obviously, you don't have to model anything, but you just have to understand, what the equation represents and how to manipulate it. So, how do you study for the math section of the ACT? So, this was the method I used. It's very similar to what I used for all sections of the ACT. Do a practice test first. That's the only way you'll know where you are at. So, and this is what you should get from it. So, as we did in the English section, we have the same 4 brackets. So, basically, first, what can you do intuitively? Like, basically, you look at the question, you can answer it as soon as you look at it. Whether it be in geometry, probability, algebra, complex numbers, etc. If you know how to do it straight away, then you're in that A bracket. Then for bracket B, basically what you can do consistently. So basically, you can be accurate at it, but like you need to think about it for a while. So you need to take some time to think about the question for you to be able to get it right. But like generally, you will get that question right, and you'll do it consistently. And then the bracket C is what you get wrong sometimes. So basically, like it's about 75 to 80% accuracy. Out of 5 questions, you might get one wrong. Like, you don't, it's not like a bracket that you're too worried about, but like also you don't want to be making that many mistakes um, in that particular bracket or concept, because you want to score as high as possible, right? So you want to look out for that. And then D is obviously like the most worrying, what you get wrong consistently. So yeah, D and C are top priorities. So you need to find review materials such as the ACT books, like subject books or the red book or the question bank, anything to find like review materials curated to that particular question type, in those categories. And remember, don't put any time pressure for DNC categories for now, because you want to understand the material well first. Like you want to understand the concept, and then later you want to like put time pressure. So, yeah. So don't waste your time by practicing A. That goes without saying. If you know how to do it intuitively, you don't need practice for it. And then when you do see yourself improving topics in the DNC brackets, you want to start practicing under time conditions. And when you do that, add B to this practice, because remember, B was I can do it consistently, but I have to take some time to think about it. So basically, you want to sort of move up the tiers as much as possible. Try and get everything to A and B, where you're not like you're minimizing the number of mistakes you make. So the timing method that I use was for paper. This was really helpful for me. Do the first 5 questions to warm yourself up, because it's the morning. You have to take some time for your brain to warm up. Do something easy, because generally what happens is, like, as the ACT math section progresses, the questions get harder. So the first questions are really easy. So yeah, use them as warm up. Do like about 5 of them, and then go straight to the back. Because once you're warmed up, this is like your prime, like, brain time. Like, you can. This is when your brain is functioning the best. So you want to answer all of the hard questions in this time. So once you do the first 5 questions, try and finish the last 10 questions, because they will be the hardest by progression. So you want to try and finish these 15 questions in about 20 minutes, and then you just continue from backwards to forwards. Because again, you at the end you want to be faced with like easier questions. So about like the questions 5 to 15, like those will be pretty easy for you to do even at the end of the test, even when you have time pressure. So for digital, for the timing method, again, the as like from what I've heard about the digital ACT, because I took the paper ACT, the difficulty isn't really dependent on the order of the questions. So I guess what I'd recommend is you mark the difficult questions as you see them. Like, if you're not able to do them, um, so they're not like a category A type question, then you just mark them and move on, and then you come back and do them again like later. Or you mark them and then you do like the first 5 that are easy, and then you mark them, you find them, and then you do the hardest questions, and then you move on, if you want to do something like that. But yeah, it's not in order, so it's a little bit tougher to do that sort of demarcation. So yeah, the ACT math isn't like the SAT math, in the sense that ACT has a lot more like different concepts. So like these are some of the concepts you might not learn in like algebra 2 or pre-calc, that might come up on the ACT. It's like, okay, so the first one is matrices. So think of matrices like data tables. It's populated in rows and columns. The main question types for matrices are addition, subtraction, multiplication, finding the determinant, and finding the inverse. But the last two are only for 2 by 2 matrices. So adding and subtracting is easy. Just add or subtract the values at the corresponding position um, from using the second matrix. So basically, like, just map out the coordinates inside the table, and like that's what you should be adding and subtracting. So adding and subtracting, you can only do it when the matrices are the same dimensions. Now for the multiplication of matrices, take a look at this example here. So basically what you're doing is you're multiplying every like possible number into that number. This is sort of the formula to do it. So for example, ABCD times WXYZ, you'd have AW plus BY for the first coordinate, and then you'd have AX plus BZ over here, and then you have CW plus DY over here, and then DX plus or CX plus DZ over here. Yeah, CX plus DZ over here. So yeah. And then for the determinants, it's a simple formula. It's for 2 by 2 matrices, it's just AD minus BC. And the only thing you'd actually use a determinant for is to find an inverse, which is using this formula. It's basically 1 over the determinant, which is AD minus BC, times, you just swap D and A, and then you make B and C negative. So this is how you find the inverse of a 2 by 2 matrix. Another common, like, sort of outlandish math concept that comes up on the ACT are vectors. So, one of the things you need to do is, like, for example, to add vectors, you want to place them head to tail, like, such as the drawing here, and draw the resultant from start to end. And then subtracting the vectors is basically the same thing, but just reversing the second vector and then adding it. And then, yeah, use the component form. So basically, like, these vectors will have x and y coordinates. So use, like, the x and y values, and, like, add or subtract using the x and y values. There will be an example later, so don't worry about this. And then this is probably the hardest question, which is basically finding the angle between, like, the angle of a vector. And you can use this by, you can use tan inverse to find this angle. So it's basically theta is equal to tan inverse of ry over rx, which is basically the horizontal component, over, sorry, the vertical component over the horizontal component, where r is the resultant. And then, yeah, adjust the angle based on the quadrant to get the correct direction, because this tan inverse will only work in, like, one quadrant. So you have to, like, adjust it depending on, like, the context of the question. So let's do some practice. So, yeah, so as we did before, we're multiplying matrices here. So we're trying to find, um, 3568 times wxyz. So as we did before, using the formula previously, we multiply row n by column n and add the two numbers, and the 2 by 2 shape stays the same when you're multiplying both of these. So in this case, the answer is J, because you have 3w plus 5y, and then you have 5x plus 8z, 3x plus 5z, and then 6w plus 8y, and then 6x plus 8z. Now for the second question, where it's a vectors question, so vectors a and b, AB and CD are shown in the standard xy coordinate plane. Um, and one of the following is the unit vector notation of the vector AB plus CD. So we're adding vectors here. So which one is the correct notation? So let's look at the vectors that we have. We have AB and we have CD over here. So we want to, like, first put them in, like, the unit form, right? That's what we said. So in our vector notation, as they call it. So count how many units long A, B, and CD are on the x and y axis respectively. So in this case, AB is 9 units long, on the x-axis, and 6 units long on the y-axis. So, like, think about it as like 9, 6, like on a coordinate sort of thing. Or in terms of proper vector notation, xi plus yj, you have 9i plus 6j. And then for, the second vector CD, it's 0 units long on the x-axis and 5 units long on the y-axis, giving us 0i plus 5j. So now you want to combine the like terms, which are I and j, by adding a, b, and c, d. So when you add this, you're basically adding 9i plus 6j plus 0i plus 5j. So 0i, nothing happens there, so it'll just be 9i plus 6j plus 5j, which is just 9i plus 11j. So the answer is E. So yeah, thank you for listening. I hope you learned something today. So yeah, visit vikinginitiative.com for more AP, IB, SAT, or ACT resources. And yeah, if you have any questions or, problems that you'd like us to solve, join the ACT group chat and ask our tutors. And yeah, you can join the ACT group chat using vikinginitiative.com. Thank you.